Hello students, welcome to my class on computer graphics. I am Shravani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. Today I will discuss the two-dimensional geometric transformation, scaling, reflection and shear. So in my last lecture, I already discussed the rotation and scaling and two different types of scaling. One is the fixed point scaling and another is scaling free scaling. So these two things I already discussed in my last class. Now I will continue that same class and I will discuss the rest of the things. So before discussion of the reflection and shear, I want to discuss another important topic which is called the composite transformation. So as you've seen in my last class that if I want to scale any object, then the scaling operation can be performed in different way. Okay, so the first type of scaling is called the fixed point scaling and second one is the free scaling. So in case of free scaling, if I scale the object, then that object will be scaled and along with that it will change its position. Okay, so in case of scaling, there are two types of scaling. One is free and another is fixed point. Okay, which already been discussed in the last class. So in case of free scaling, the object will change its size. Along with that, it will change its position also. But in case of fixed scaling, the object will change its size. That means its size will increase or decrease, but its position will not be changed. Okay, so if you see that this is the axis, this is x-axis and this is y-axis, and the same example which I have taken in the last class, I will take the same example. Consider a square like this one. Okay, and we want to scale the square. Now in case of free scaling, if I want to scale it, that means if I want to scale the square along x direction, that means the scaling unit Sx along x direction is 2 unit and the scaling unit Sy along y direction is 1 unit. So in that case, that same object will be scaled and its size will be like this one. Okay, the size will just increase twice. It will be somewhere like that. So you can see that along with the change of the size, the square converted into rectangle and it also changes position. So this is called the free scaling. Now if I want to change the shape of the object, but we don't want to move its position like that. So consider this again the coordinate system. Okay, and for the same square, if you want to perform the scaling operation with the same unit of scaling, so in that case, what you can do, you have to scale it. Okay, and the scaling operation will be performed like this one. So here you can see the object is scaled. So this was the original size of the object, and after scaling, the size of the object becomes this one, the entire rectangle. Okay, so here along with the change of the size, the rectangle has not changed its position. So this type of scaling is called fixed point scaling. Now here the scaling operation is performed based on a fixed point. So here you can see all the points. So as you can see for that rectangle, there are mainly 4 points. So this is, we can say this is point P1, point P2, point P3, and point P4. Okay. So before that, I should mark it like this is P2, this is P3. We mark it the change point as P2 dash, P3 dash, and P4 dash. Okay. And the previous point was P4. So you can see P1, P2, P3, P4 is the previous square. And after scaling it, the new rectangle will become P1, P2 dash, P3 dash, P4 dash, or P4. Both are equal points, same points. So here you can see one important thing you can notice, that the point P1 has not changed its position. Whereas you also can say that, ma'am, the points P4 also has to change its position, but instead of 1, so as we consider the scaling factor along y direction is 1, but instead of 1, if I can choose that it is 2, so in that case the size will increase. Okay, so its size will change and the new size will be something like that. So it will be like that. If you consider the scaling factor along y direction is 2 unit, then the new square will be something like that, where the point P4 dash will be this one. So this one will be our P4 dash. So whatever you can notice, one important thing you can notice over here, that the point P1 has not changed its position. So that's why it is called the fixed point scaling. Okay. So here the scaling operation is performed in general, but the point on which the scaling operation is performed, based on which point? Based on the point P1, the scaling operation is performed. Now here, how this scaling operation is performed, that is very important thing. So you notice the entire operation. So we want to scale this particular square. Okay. Now how this scaling operation is performed, you observe the step-by-step approach. So in the step 1, what we have to do, we have to move this object square, we have to move this object square from its original position. So we want to perform the scaling operation based on the fixed point, this first point of the square. So what we have to do, we have to move. So this was the original position of the square. Now we have to move this square along the origin. That means the point based on which we want to perform the scaling operation, the point which we want to keep fixed, that point we need to move to the origin. So as here we want to keep the point P1 fixed, so we are moving the point P1 towards the origin. So we mark it P1, P2, P3, P4. Fine. So we are moving the point P1 to the origin, and subsequently all the points will be moved accordingly. So let us say this is new point set P1 dashed, P2 dashed, P3 dashed, and P4 dashed. Okay. Now after performing this movement operation, what we have to do? We have to perform the scaling operation. Okay. So we will perform the scaling operation. So you observe the next step. So in our next step, we will perform the same scaling operation with respect to x-axis and y-axis. Okay. So let us say, consider, so this is our y-axis and this is our x-axis. So we will perform the scaling on this object, and what is the scaling factor? We want to scale 2 units in x direction and 1 unit along y direction. So the same object will be scaled and it will be something like that. Okay. So after scaling, the shape of the object will be like that. So how you are performing the scaling operation, that was discussed in the last class. So after scaling, you can see that the new shape of the object will be this one. Okay. So we should say this is the step 1. So in the step 1, we have to translate the object to the origin with respect to the fixed point. We have to move the fixed points to the origin. In the step 2, we have to perform the desired operation. Okay. Now, in our next step, what we have to perform after performing the desired operation, scaling, whatever operation you want to perform the scaling, we have to take back the object to its original position, okay, based on the fixed points. So you can see that this was, let us say this point P1 is the XY. Okay, so XY is the original position of the point P1. So what we will do after performing the scaling operation, the new coordinates will be become P1 double dashed, P2 double dashed, P3 double dashed, and P4 double dashed. So those are the coordinates of the new rectangle. And what we have to do, so this P1 dashed is nothing but this point P1 whose position was XY, and now the location of the coordinate of the P1 dash is 0, 0. So what we have to do, we have to move the point P1 dash to its original position P1, which is XY. So what we will do, we will move it. So if we move it, it will be something like that. Okay, so we are moving the point P1 double dash to its original position. So now we consider the new point. We say it is P1 triple dashed. This is P2 triple dashed. This point is P3 triple dashed, and this is P4 triple dashed. Okay, so now what is the coordinate of the P1 triple dash? The coordinate of the P1 triple dash is same as P1. So this is XY, this is also XY. So this is the final step, or we can say it is a step 3. So now you can see our scaling operation has been performed completely. So what are the steps we need to perform to for the fixed point scaling? To perform the fixed point scaling, first we have to move the point P1 to the origin. That means the fixed point based on which we want to perform the scaling operation. That point I need to move to the origin. So I am moving it. Next, perform the scaling operation. Next, after performing the scaling operation, go back to its original position. That means send the point P1 to its original position from the origin. So as we are moving the point P1, the entire object will be moved accordingly. So it seems that after performing the scaling operation, the object remain is at its own position. Okay, so what are the, from this step by step approach, you can see what are the operation we need to perform. As first operation is move to origin. So that means step 1, what we need to perform, we need to perform translation. Okay, so first operation we need to perform the translation. And what is the translation amount? The translation amount Tx is minus x, and the translation amount Ty is minus y. So as you see, the original position is xy, and I want to move the xy to the origin. So that means I have to move minus x unit in the x direction and minus y unit in the y direction, so that I can reach to the origin. Okay, so this is our translation amount. I need to translate the points P1 to the origin along with all the points of the object. Number 2, after performing the translation operation, I need to perform the scaling operation, and where the scaling factor is Sx is equals to 2 unit and Sy equals to 1 unit. Now you can choose your, as per your desired operation, desired need, you can choose the scaling factor. And the number 3 is, after performing the scaling operation, we have to perform the reverse translation. Okay, to send back the object to its original position. So at the step 3, we have to perform the reverse translation. So in case of reverse translation, what we have to do, this we have to move 0, 0 to its position xy. That means the translation factor Tx will be x, and the translation factor Ty will be y. Okay, so those are the different translation factor we need to perform this. So using those translation factor, we need to multiply the points with the respect of translation matrix, and we can move back the object to its original position. So if we write the entire thing in terms of the matrix, so how it looks like? So as you know, so this P is my point set. Okay, so let us write the point set is like this one. So those the point set is x1, y1, 1, x2, y2, 1, x3, y3, 1, and x4, y4, 1. Okay, so those are the point sets, and we want to consider that we want to perform the scaling with respect to a fixed point, and the coordinate of that fixed point is x1, y1. Okay, so here the coordinate of the fixed point is x1, y1. So with this point, for what operation I need to perform? First, translation. That means I need to translate those points to the origin, and what should be the translation factor? Minus x1 minus y1. Okay, so I have to multiply the translation matrix with this point matrix. Clear? So what will be my translation matrix? My translation matrix will be 1, 0, minus. So better, I should write tx, 0, 1, minus ty, 0, 0, 1. So what is in this example? What is our tx? Our tx is x1, and what is our ty? Our ty is y1. Okay, in this example. Now after doing so, what we have to do? We have to perform the scaling. So you know what is the scaling matrix? The scaling matrix is x0, 0, 0, 0, sy0, and 0, 0, 1. Okay, so that is our scaling matrix. Fine. Now after performing the scaling operation, again we have to send back the points to its original position. That means again we have to perform the translation, but here the translation is reverse translation. So we need to perform, we have to write the same translation matrix 1, 0, but here instead of minus tx it will be tx. So it is 0, 1, sorry, 0, 1 ty, and this will be 0, 0, 1. Okay, so this is all about. So here you can see that we are performing multiple transformation. So we need to perform here 3 transformations. So how many transformation we want to we are performing on the point set P? We are performing 3 transformation. So this type of transformation is called the composite transformation. Okay, so this is called composite transformation. Okay. Now, clear what is composite transformation? So what you can do, you can multiply all the matrices, you can keep it as it is, or you can perform the multiplication from left to right. Okay, from your left to right you can perform all the multiplication. You can perform multiply this matrix with this one, with this one. So which will be your composite transformation matrix? So instead of writing all the 3 matrices separately, you can multiply them, and after multiplying you can write down the final answer. Okay, so your final answer will be, if you multiply all the 3 matrices, you can see your final answer will be Sx 0. Okay, now it will be 1 minus Sx, this is a scaling factor, into the translation amount Tx. Okay, now next one will be Sy 0, the translation unit Ty, and 1 minus Sy. Okay, and the last one will be, so just a minute, this Sy will be not, this is not Sy, this will be 0. If you perform the multiplication, you can see it will be 0, and this is Sy. Okay, and the last one will be 0, 0, 1. Now instead of writing all 3 matrices separately, what we can do, we can multiply them and we can write it as a composite form. Okay, so this composite matrix can be also written in this format also. format. So this matrix is called the composite matrix, or you can keep it as it is, keep them as it is. Okay, so this is all about the composite matrix. So I am writing the points. So in this case, my object has 4 coordinates. So if you have any object which has more than 4 coordinates, you write down all the coordinates and just use this, perform one multiplication base and put the value on these equations. So you can see your, after doing all operation, whatever the points you will get, you will plot them, draw the line, and you can see your scaled object. Okay, so this entire code is running behind any scaling option for any drawing application. Okay, so I think it is clear which is composite transformation. Now the next topic which I want to discuss is called the reflection. Okay, so the next topic I want to discuss is called the reflection. So this reflection is same as the reflection which we can see in the mirror. So first, let me show you the problem. What is the reflection? So this is the x-axis and y-axis. Fine. So better write the axes over here. It will be easy for our to draw. And we have to increase the scale also. Fine. Now, consider you have a triangle like this one. Okay. Now, if you want to if you want to perform the reflection operation, so in that case, what will happen? The same triangle will be drawn over here. The same triangle will be drawn over here, but it will be reflected. Okay, so it will be something like that. So this will be our reflected triangle. So this is our original triangle. So this is, you can say the point is P1, this is P2, and this is P3. And after performing the reflection, you can consider this x-axis as the mirror. Okay, so through the mirror we are seeing the image. So we put the image this side of the mirror, and we can see the reflection of the same image on the other side of the mirror. So it is called the P3 dashed, P2 dashed, and P1 dashed. Okay, so this is nothing but the reflection. So here you can see we are performing the reflection operation for this particular object with respect to x-axis. So the reflection are of different type. Okay, so in this case we can say it is a reflection about the x-axis. So you from the different axes you also can see that we can perform the same reflection operation with respect to y-axis also. Okay, so we can write them, that the reflection of y-axis. So let us write what are the different types of reflections are there. So first one is the reflection. So reflection about the reflection about x-axis. Okay, the next one is reflection about y-axis. And there is also another type of reflection which we can say, we can write that reflection with respect to origin. Okay, So basically there are three types of reflection, and you also can, based on those three types of, those are the main category of the reflection. So based on those basic categories of the reflection, you can perform any type of reflection, you can implement any type of reflection later. Okay, so this first image which I drawn over here, this image is the shows you the reflection of the object with respect to x-axis. Okay, similarly, if I want to reflect with respect to y-axis, so it will be same like that. So reflection with respect to y-axis will be something like that. So this is our y-axis. So this is our x-axis. Okay. Now we want to perform the reflection with respect to axis. So it will be same like this one. You can, okay, so you can copy the same object and you can paste it also. Okay. So let us drag it and put it over here. So here you can see this reflection operation has been performed based on the y-axis. So this is called the x-axis, this is x-axis, this is our y-axis, and this reflection is the reflection about y-axis. So let us say this is point P1, this is point P2, this is point P3. So here this P1 will be mapped over here. So it is our P1 dashed, it is our P3 dashed, and it is our P2 dashed. Clear? And now there is another type of reflection which I told you, that it is a reflection with respect to origin. So now I will draw another diagram which will show you how we can reflect the object with respect to origin. So the same, this is our y-axis, this is our x-axis, and consider we want to draw so this will be our object. This is again the same triangle we will draw over here. Okay, now if you perform the reflection with respect to origin, you can see that the same triangle will be drawn on this side with of the, so if it is drawn in the first quadrant, the same triangle, after performing the reflection with respect to origin, the same triangle will be drawn in the third quadrant. So here we can write, this is the point P1, this is point P2, this is our point P3. So in our reflected object, it will be our P1 dash. Okay, this will be this is the P2 dashed, and it is the P3 dashed. Okay, so if you just flip the paper, so if you flip the paper along this origin, if you flip the paper along this origin, this triangle will be superimposed on this triangle. Fine. So this type of reflection is called the reflection with respect to origin. So there are basically three types of reflection. One is the reflection with about x-axis, reflection about y-axis, and reflection with respect to origin. And from the three diagram, you can easily derive the transformation matrix. Okay, so we will derive the transformation matrix for the reflection along x-axis. So we will derive the transformation. So let us write down it, the reflection matrix. This is our reflection matrix. About x-axis. Okay, so we are deriving the reflection matrix for the performing the reflection about x-axis. So what will be the matrix? The reflection matrix, let us say, Rx. Rx is the reflection matrix with respect to x-axis. So the what will be our reflection matrix? From the image, from the diagram, you can see in this quadrant, all points are plus plus, positive. And in this quadrant, the value of x is positive, but the value of y is negative. Okay, clear? Here, the value of x is positive, but the value of y is negative. So, if it is so, then here, if the point P1, so let us, P1 is nothing but x1, y1, okay, P2 is x2, y2, and let us say P3, x3, y3. So if it is so, so in the positive quadrant, all are plus x1 plus y1 plus x2 plus y2. So while it will be reflected with respect to x or x-axis, so in this quadrant, the value of x will be plus and value of y will be minus. But only the sign will change, only the sign will change, but the value of x and y, that will remain same. Clear? So if I want to perform the reflection with respect to x-axis, so this will be nothing but this one. So how we can change? If I want to make P1 x1 y1 to P1 dashed x1 minus y1, so if I want to make this type of changes, then what we have to do? I have to multiply minus 1 with the value y1. So we are doing so. So we are writing 1 0 0 and then 0 minus 1 0, then 0 0 1. Okay. So here you can easily see that if I write like this one, 0 0 1, and if my points are like x1, y1 and 1, if our point is like this one, and if you multiplied it, so how it will be multiplied? Okay, 1 into x1, 0 into y1, 0 into 1. So after performing the multiplication, it will be only x1. So now while you will perform the multiplication with the second row with the first column, so it will be minus y1, and similarly it is 1. So you can see after performing the multiplication, the point P1 is converted to x1 and minus y1, which will be projected on this quadrant, fourth quadrant. Clear? So this is the reflection with respect to x-axis. Now, if we want to perform the reflection about y-axis, you can easily generate the reflection transformation matrix. So now we will write down the reflection matrix. So we are writing the reflection matrix along, or rather write about y-axis. Okay. So if I want to perform the reflection about y-axis, the same thing is there. Second quadrant. In this quadrant, everything is positive, and in this quadrant, value of x is minus and value of y is plus. Clear? So same operation we need to perform. We need to multiply the x value by minus 1. So our reflection matrix along y direction, let us write down, it is Ry. So our reflection matrix along y direction will be minus 1 0 0 0 1 0, and this will be 0 0 1. Okay. Now, so same thing, if you perform the multiplication of this reflection matrix with any point set. So I am just showing you one example, one instance. Minus 1 0 0 0 1 0 0 0 1, and if you multiplied it with x x1 y1 1, you can see minus 1 into x1, so it will be ultimately answer will be minus x1. Next one is y1, and the last one is 1. Okay. So this is the answer. So you can see the point is converted. The point which belongs to the first quadrant will be now converted to the points of the second quadrant. Clear? Now next is the reflection. So what is the next reflection? This one. So we are performing the reflection with respect to origin. So here with respect to origin, we are performing the reflection. So here you can see everything is positive and here everything is negative. Clear? So we are performing the reflection with respect to origin. Fine. Now if you want to perform the reflection with respect to origin, so your reflection matrix with respect to origin will be same. Everything will be, all the x value and y value all are will be negative. So we will just write down -1, 0, -1, because we have to multiply the x with -1 and the y is also with -1. So it is our reflection matrix with respect to origin. Clear? So this is all about the reflection. So the same thing I will show you, the same operation I will show you for the point set P1, one instance. So if I want to reflect the point P1, that means the x1, y1, 1 with respect to origin, what will be its coordinates? So what we have to do? We have to multiply the reflection matrix with respect to origin with the point matrix x1, y1, 1. So if you multiply this, what you will get after multiplication? You will get -x1, -y1 and 1. Okay, so this is the reflection with respect to origin. Clear? Now there is another type of reflection which is called the reflection. So this with reflection with respect to a line that is passing through the origin. So those three are the basic reflection. Now there is another category of the reflection which is very common. So that is called the reflection with respect to a line that is passing through the origin. Fine. So it is like that. So consider this is the coordinates. This is our coordinate system. So this is our y and this is our x-axis. And here there is a line which is passing through the origin. Fine. And you know, if a line passes through the origin, the equation of the line is y equals to x. Clear? Now, the line passing through the origin with the equation y equals to x, how we can reflect the object? So if I want to reflect the object with respect to this one, so it will be like this one. So let me draw the object first. So consider the point. So this is the object. I want to reflect this object with respect to the line y equals to x. So how we have to, after reflection, what will be the impression of the object? The impression of the object will be something like that. Exactly. So something like that. So here you can say if it is point P1, it is point P2 and it is point P3. Then after reflection, it will be your P1 dashed, it will be your P2 dashed and this is your P3 dashed. And as the equation of the line is y equals to x, so in this part of the quadrant, if a point P1 is represented by x1, y1, so in this part of the quadrant, the same point P1 dashed will be represented by the coordinate y1, x1. Clear? So that's the opposite. So here if a point P1, so let us say for example, if the coordinate of a point P1 is 2, 3, in this part of the quadrant, the same point P1, if you reflect it, the coordinate of the reflected point will be represented by 3, 2. Just y will be x, y will be treated as x, and x will be treated as y. So if it is so, what we have to do, how to write down the reflection matrix? So here, the reflection matrix for the line y equals to x can be written as, so I need to get y value in with respect, while we are going to get the x, and the value of the x will be y. So it is very simple. It will be something like that. So x will be multiplied by 0, y will be multiplied by 1, and the weight factor will be multiplied by 0. Similarly, here it will be 1, 0, 0, and the weight factor is 0, 0, 1. Okay. So this is the reflection matrix. You can see how we can get the reflected one. So consider an example. I want to reflect the point x1, y1. So what I will write? I will write the point set like 0, 1, 0, 1, 0, 0, 0, 0, 1. Okay. And then the point set is x1, y1, and 1. So what will happen? 0 will be multiplied with x1, 1 will be multiplied by y1, and 0 will be 1. So ultimately the answer will be y1, x1, 1. Okay. So that is all about the reflection with respect to origin. Clear? With respect to a line y equals to x. So there are different types of reflection. One is the reflection about x-axis, reflection about y-axis, reflection with respect to origin, and the last one is a reflection with respect to a line. So in this way, so last one is just a derivation. So in this way, you can perform the different types of reflection with respect to some other line y equals to mx plus c. So accordingly, you have to generate the transformation matrix. Clear? So now next we will discuss the another important transformation, which is called the shear. So the next topic of our discussion is shear. Now what is the shearing effect? The shearing effect means this is a type of the transformation which distort the shape of an object. Okay. So it seems like that we are stretching the object from one end, keeping the other end fixed. Okay. So this is called the shearing. So you can see if we draw the object like that. So if you see that this is our coordinate system. Okay. And this is our coordinate system. Fine. Y-axis and x-axis. Now consider an object like this one. So what you can see over here, for this particular object, so this object, the one surface is on the x-axis, one edge basically of this object belongs to x-axis, and this is the other edge whose line is parallel to x-axis. Now if you want to shear this object, what we will do? To perform the shearing operation, we will keep the base fixed and we will move the other part. So if you move the other part of the object, you can see that the shape of the object will be distorted. Clear? So this is called the shearing. So this is our x1, y1, not x1, y1, we should write it point P1, P2, this is P3, and this is P4. So 4 points are there, P1, P2, P3, P4. And after performing the shearing operation, it will be, the P1, P2 will be remain as it is, but P4, P3 will be changed, and it will be P4 dash and P3 dash. So this is our object. You can see the shape, we got a distorted shape of the object after performing the shearing operation. So if I want to perform the shearing operation along the x direction, so it will be something, so this is a shearing along the x direction, fine. So the shearing operation along the x direction, the transformation matrix we should write is TS, transformation matrix for the shearing. Okay, so let us write it something like that. The transformation matrix will be 1 SHX. So SHX is the shearing factor. That means how much you need, I want to shear along the x direction. Then 0, 1, 0. So here you can see we are not changing the y value. So for P1, P4 and P4 dashed, the y value is remain same. Okay. And similarly for P3 and P3 dashed, the y value remains same. Fine. So here we are not changing the y. Fine. So that's why it is called the shearing matrix along the x. We are changing the value of the x only. Fine. So after if you got this matrix and if you multiply this matrix with some other points, that means if you multiply all the points of the object with this coordinate, so what you will get, you can perform the shearing operation. Okay. So we can write the equation, that coordinate position of the shearing equation, we can write it. That means the x dash, new x value will be x plus the shearing factor, okay, dot y value, okay, and the y dash, that means the new y value will be same as y. So this is all about the shearing. So if you got the shearing matrix, you can multiply the shearing matrix with any point set, and what you will get, you will get the changed value. Clear? So if there are the different types of shearing, you can perform the shear operation along y direction also, and you can perform the shearing operation with respect to origin. So there are different types of shearing operation you can perform. So that is all about all the basic transformation which we can perform on the 2D object. So this is called the transformation of the 2D object, and the important thing is that by combining one transformation with the another transformation, we can perform another set of operation which is called the composite operation. So as you can see earlier in the beginning of the lecture, we are performing the scaling operation with respect to fixed point, and to perform this operation, first I need to perform the translation operation, and then we can perform the scaling operation. So here two operations are merged together, and with the help of these two operations we are performing something else. Clear? And same thing you can also perform for the rotation also. So previously I showed in my last lecture, I shown you that while you are performing the rotation, you are performing the rotation with respect to origin. That means if it is your y-axis and if it is your x-axis, and if you want to rotate this point P, so what we are doing, we are joining this point P with respect to origin, and then we are performing the rotation operation. So this here the rotation is performed with respect to origin. But if it is like so that you have the point P and you want to rotate this point P with respect to point P1, so what you have to do, you have to perform the rotation like this one. Fine. So you have a point P you have a point P1, and what you want to do, you want to rotate this point P with respect to point P1. So basically this line should be rotated, and suppose we want to rotate along the angle theta, so this will be your theta. So to perform this type of rotation, again the same set of operation you need to perform. First you need to translate the point P1 and along with the P, that means all the points present which needs to perform the rotation with respect to P1, all points needs to be translated to with respect to origin, then perform the rotation and then take back. So this is the basic logic to perform any operation. So if any operation is performed with respect to origin, and if you want to perform the same operation with respect to something else, it may be points, it may be some line, whatever. So if you want to perform the operation with respect to something else other than origin, in that case first step is you have to bring the entire thing with respect to origin, bring the point with respect to you want to perform the operation to the origin, perform the operation, and again get back the entire thing in its original position. Fine. So in this way you can perform any operation as per your need, as per your requirement. Clear? So that is all about the transformation. In my next class, I will discuss the different problems. So I will show you some problems, mathematical problem based on all this 2D transformation. And I will show you how the composite transform, how we need to solve the problem with the help of the composite transformation, with how we can solve it. Okay. So thank you for watching my video.